Hello everyone, this is the lesson for Module 35. There was no video on Module 34. We're going to cover that one very briefly in class. It's a very short module. And now we're going to move on to Module 35. So this is all about different types of problem-solving strategies and obstacles to those strategies. The two main problem-solving strategies we're going to be discussing are algorithms and heuristics. And we're going to be discussing some specific types of heuristics. So algorithm is like a recipe. It's a step-by-step rule or procedure for solving a particular problem. So it's like using the FOIL method in algebra, or following literally like a food recipe to bake cookies. You put in this much sugar, this much flour, right? And you follow exactly what the recipe says. A heuristic is a shortcut. It's a thinking strategy allowing us to make quick judgments and solve problems. So it's fast, that's a shortcut part of it, but it's also error prone. You can make mistakes. So trying to undo this word, which, by the way, if you haven't gotten it yet, the word is psychology. But let's say you didn't know that. There's different ways you could try to figure it out. If you want to use an algorithm, that would take forever. If you try each letter in each of the 10 positions, there are over 900,000 possibilities. What you more likely did, and if you probably did it in your head, you did it without realizing it, you group letters together that often appear together, like the C and H often go together, G and Y. You didn't, in your mind, put any Y combinations. I can't think of any English words that have two consecutive Ys in them. So that would be using a heuristic. It's a shortcut, and in this case, one that was not error-prone, that allowed you to come to the answer much more quickly. Another example, like finding hot chocolate mix in a supermarket. An algorithm approach, you'd have to go to every single aisle, and you look up and down every aisle. Never mind the fact that it's probably not in the aisle with the cleaning products. Maybe it was misplaced. Maybe it was put there for some weird reason. You would look in every aisle. And so then you would definitely not make a mistake. If you went through every aisle, the plus side is you would definitely find the hot chocolate mix. The negative side is that it might take you 5 hours looking through every product in the supermarket. The heuristic approach, you would go to the aisle with chocolate or cakes or cake batter, and you might be wrong. It could actually be in some other aisle. Maybe it's in the candy aisle instead of the cake aisle. So you might make a mistake. It's error prone, but you would figure it out much more quickly. And even if you made a mistake 1 or 2 times, by your 3rd or 4th try, you'd find the hot chocolate. Another way to solve a problem, and this goes back to our monkey experiment, right, is insight learning. Right? Remember Wolfgang Kohler with the monkeys when they realized all of a sudden, aha, I can just put the crates down to jump up and get the bananas. When you realize something suddenly, it's not a strategy-based solution. It's not a heuristic or an algorithm. It just comes to you. Another way we try to solve problems, and this is somewhat related to heuristics, is confirmation bias, searching for information that supports our preconceptions, our preconceived notions. So we often, in trying to solve problems, we have a mental set. We try to solve a problem in a particular way with a mindset of what's worked for us previously. So to form 4 equilateral triangles with these 6 matchsticks, we may not think of doing it in this way. We may be trying to kind of put them as 4, hey, how can we make 4 separate triangles with only 6 things? We would need 12 things, right? Without realizing that, the matches could be in 2 triangles at once. That's thinking outside the box. Here's another example. If you were only given these supplies, how would you, let's say, and you were told, make the candle stand up. Wait, I don't have a stand. How can I make the candle stand? Well, you could use the empty matchbox as the stand. I apologize. That it's not on this slideshow. We will have it. We'll discuss it in class. But that is an example of overcoming something that's called functional fixedness. Functional fixedness is when it's a bad thing. It's when in your mind you're unable to think of an object as anything other than its main intended source. Classic example: you're at a picnic, and it starts pouring, and it's like, oh no, we didn't bring an umbrella. We're gonna get soaking wet, without realizing that the picnic blanket that you're sitting on could double as a protection from the rain if you put it over your head. Not thinking of things, if you only think of something, this is the opposite of divergent thinking, which we discussed in class. Divergent thinking is all about being creative and thinking about many different uses for something, or solving a problem in many different ways. This functional fixedness would be an example of convergent thinking, thinking there's only one way to solve a problem, only one way to use something, and not thinking that the matchbox could be the stand or that a blanket could be your umbrella. That is, all right, we're going to talk about two different types of heuristics. The representative or representativeness, sometimes it's said that way, heuristic, is basically stereotyping. It's judging the likelihood of things in terms of how well they seem to represent a particular prototype. So, example, a person is short, slim, and likes to read poetry. Is this person most likely to be a truck driver or a professor of classics at an Ivy League school? That person might represent our stereotype or image of a professor of classics, but statistically, there are thousands more truck drivers in America than there are professors of classics. So more likely, if we're describing a random American, there's a higher chance actually that person is a truck driver. Another example, and this is where the implicit, unconscious racism and sexism comes in, is if I say, hey, imagine a pilot, and you're thinking of a male automatically. Or if someone says, imagine a terrorist, and you think of someone of a particular race or religion. A pilot there's no reason that a pilot has to be one gender or another, nor is there any reason that a terrorist is more likely to be, could be one race or gender or religion or another, but we think about what's more stereotypical in our brain and jump to that. And it's an example of how even when we try not to be racist or sexist or prejudiced, it could come across subconsciously. An example, let's contrast that to the availability heuristic. Now, the word availability refers to what's available in your brain, what's available in your memory. If things come to your mind readily, for whatever reason, we think they're more common. So, and that's oftentimes it's based on what's on the breaking news, what's on the news on TV. You're more likely to see news stories about murders or about airplane crashes. So you may think, oh my God, I saw this story 3 years ago about a plane that crashed. I'm never getting on a plane again. When in reality, the chance of a plane crashing, or let's say, is not even on this chart actually. It's probably somewhere down here. The chance of dying in an automobile accident is so much higher. But they don't report about automobile accidents, deaths every day, because there's so many of them. And they kill 1 or 2 people at a time, which is devastating and tragic for those who die, but it's not particularly newsworthy on a nationwide scale, whereas that one plane crash every 10 years that kills 100 people makes front page news for a week, and people think, oh my God, planes are so dangerous, because it's vivid and available in our brain. Overconfidence. We discussed this, I think, in an earlier unit. Just a tendency to kind of be overly confident with whatever our beliefs and judgments are. We're not going to change our mind because it's kind of related to confirmation bias. We believe firmly whatever's already in our head. All right, belief perseverance, two sides of the same coin, similar to confirmation bias, similar to previous terms. Just, you continue to believe what you believe, even in the face of conflicting evidence. Framing, we talked about that in the last module about memory. It's not just when you have to remember something from a distant past. Even when you're asked about your opinion of something in the present, if you're asked, do you think that smoking should be legal versus do you think smoking should be prohibited, it's asking the same question in two different ways, but people are less likely to say something should be prohibited. So they might say, no, it shouldn't be legal, and no, it shouldn't be prohibited. It's contradictory, it's conflicting. That's just how people talk sometimes, because it's just all the way an issue is framed that subconsciously affects our decision-making process. All right, intuition, we use our gut, right? People say, go with your gut. What does your gut tell you to do? It's often adaptive. Sometimes our gut is tapping into some of our instincts, but it's, of course, born of experience, not of empirical data. Use it with caution. Last but not least, these two terms you need to know, and they are not in your textbook. So not in book, so pay attention. Inductive versus deductive reasoning. Inductive is when you start with something very specific and move to a general principle. Right? One person, so this could also be a recipe for racism. I know one black person and he is mean, so I think all black people are mean. Or it doesn't have to be a negative thing. It could be positive. I know one person from this country and they're really nice, so hey, I want to go visit that country one day. It must be a great place, right? Sometimes inductive reasoning could be correct, right? Those two examples I gave are ridiculous, obviously. But let's say you're going on a college tour and you spend 30 minutes in a college and you get a really good vibe and impression from the couple people you meet. You may say, wow, these few people are nice and this campus looks nice, so I bet a lot of other people are nice too. And again, it's not foolproof. Maybe you just met a few nice people on campus, but there is a good chance that it's a nice campus, that the people you met are representative of that. But it's definitely very error-prone, inductive reasoning, because you're judging from a small number to a much larger number. Deductive reasoning goes from the general to the more specific. And here, you can't make a mistake. If the conclusion is always true if the premises are true. Example, all apples are fruits. Red Delicious is a type of apple. Therefore, Red Delicious are fruits. There's no two ways about that. Thank you, everyone, for listening and tuning in. We'll have one more video coming out Thursday night on Module 36. Take care.